All right.
All right, shall we start?
Yes. Well, hey Mike, it's been a while.
Hey,
How are you doing?
very good. You?
I'm doing great. I am today enjoying some very summery weather here in Berlin. It's currently 37 degrees Celsius, which I think is close to 100 in Fahrenheit. So you see my little yeah, you see my little fan back there.
And you're definitely not
So
used to it.
but I've not break a sweat yet, but maybe this coding session today changes it. But yeah, I'm excited to get back into the groove, and I think we've gotten some like great feedback and some great ideas for further effect time sessions, specifically about like doing some more beginner targeted content, which was sort of the idea more from the beginning anyway. But we felt like back half a year ago or so when we were starting with effect time that there was still more ground to cover first before effect can really be a bit more beginner friendly. But I think we're approaching that point now, so I think it's a good time to start creating some beginner level material that people have an easier time getting into it.
Disclaimer, we're still targeting an alpha release, so hopefully everything goes well, but we're still
Yeah,
before RC.
I think we could probably find excuses to delay this sort of material, the creation of this sort of material, like for yet another month and yet another month. But I feel like now is probably the right time just to get a first version of it going. Maybe it's obsolete in a couple of months, and then we'll do another version, or
No,
maybe
no,
in a
no.
year.
It
But
the
let's yeah.
anything we see today or in these sessions should pretty much stay roughly the same. It's more around maybe we might discover bugs in implementation because we are still in the process of porting everything back.
Sounds great. Awesome. So I think you've prepared a fun little exercise here, which I think is comprehensive enough that we won't be able to get through it today within the course of an hour or so. But it's going to probably take us a few sessions. But I think that's great. That probably allows us to get into various aspects of effects and like and makes it more of a real world project. So the project that you've suggested is this Mars rover Kata on this like very web 1.0 ish website. um,
0 point.
so no, I appreciate it. So yeah, so I have actually not done this sort of exercise here before, in and like in no other programming language or whatever. So this is the first time I'm seeing this. So I'm pretty new to like to this domain. I haven't been to Mars yet. So what this is about is that we're going to implement a Mars rover. Um, let's see how production ready it will be. But we'll give our best, I guess. And so yeah, my task here is that I'm part of the team that explores Mars by sending a remotely controlled vehicle to the surface of the planet. And we want to develop an API that translates a command sent from Earth to instructions that are understood by the rover. And so there's a bunch of different requirements, which I don't think we have to go through all of them right now, but
No, and I would suggest also ignoring part of the rules because I believe this is definitely from a 1.0 era as
all
a
right,
also as a kind of specification,
cool.
but it
So
presents a very good domain to explore. IO, pure domain logic, ADT representation, serialization, deserialization. We don't have to build an API. I usually build it as a small CLI tool. So like that reads configuration from the local file system, that opens up a console, and that accepts command directly. So this is kind of the same simplified model that I usually use, but it's really nice because it
got it.
covers any
But
aspect.
yeah, you mentioned you gave a few workshops based on that already, so
Yeah,
you're
I have
probably
definitely.
quite familiar with it. So we're basically starting from scratch here, or almost as from scratch. We're going to use this effect starter, which is relatively new, but was just in time created for this video.
Just in
And I
time
think
compiled, come on.
we'll probably try our best to keep it up to date, etc., and like try to find the right middle ground of like not putting all the tools in it, but the ones that like are most commonly used. But feel free to just add your own like def dependencies, etc., whatever you need to be productive. So I've just opened it here in Gitpod, and I think the project has, as a foundation, has like, as it's a nice VS Code feature, has some tasks set up. So I think we have a build watch task and a test watch task. So that's very similar to the projects that I'm working on. So I'll probably just already start the build.
Or otherwise, you can even start the test watch and it'll start automatically build.
Perfect. All right, for next time then. So yeah, so I think this is like a good starting point for anyone like with the starter, just getting the build running in the background, so that we get TypeScript errors like here nicely in VS Code. But I think besides that, the project is probably very minimal. So let's just explore this, what we have here. So it's very bare bones. I believe this starter here uses sort of like a companion project of the of effect, or in the effect ecosystem, called like, it's a extension of TypeScript called TS plus. I think for this series we're going to use it, but I think there's also going to be a starter project that will just be using plain TypeScript. So it's kind of up to you, but I guess here we'll explore what this additionally provides as benefits. So yeah, let's look into it. So we have like our main, I guess that's like our entry point if we want to run it.
One thing, if you notice, you have to click allow that. Allow there.
Okay, yeah. That is for like TS plus that we're gonna use
precisely in,
Got it. So,
in the IDE.
Yeah. So I think TS plus should be like a small aspect here of like of these sessions. It's more about effect, and it's just like one way how you can use it. So, but if we are looking into the package JSON here, I guess, this is where we're gonna see, okay, it's like has effect in it, has like TS plus in it, and that's basically it. So here we have our in packages app. So this is already set up as a monorepo in case we want to split things up later. For now, we'll probably stick with one package. But it's
very nice to use Yarn with the workspace functionality, because clearly it links packages directly, not modules, so you can directly resolve them.
For me, like almost every project I've been working on, it can start out as small as once. After like a few days latest, I have this use case where I want to share some code, and so yeah, it's good to have like a monorepo set up here right away. So main, I guess this is just our entry point into an effect app. So
which should be the only unsafe entry point of our application.
Unsafe, I guess is maybe like a new term for some people listening to this. Don't get scared of like the word unsafe. It actually has less to do with like unsafe for like in other programming languages like Rust, etc. But it rather like effects allows you to build your program in a way that basically reduces the places where stuff could go wrong to fewer and fewer places, and where we can't guarantee for anything is like at the place where you actually do start your code, and this is why it's
basically unsafe. It means it breaks referential transparency. It's unsafe to move around. Those are the things you can't refactor.
So, and I guess we can later get into the term referential transparency. I guess
I think the easiest description is literally, it's not safe for you to take it and move it around. You can't refactor it just by moving out things.
Got it. and on the flip side, that means like everything else we can basically very easily refactor, which is one of the amazing benefits of Effect. Anyway, let's not get ahead of ourselves, but I guess we're going to spend the most time really like building up our program. So the program right now is literally just like a hello world where we console log. So that's great. We're going to come back to that in a second. Let's just take a look here. Global, I guess this is just like some global types that we have available here with
If
like
you look
TS.
in the program.ts, we do effect.sync.
Got it. So we have
effect
not
doesn't
imported
exist.
this.
We have not imported it. Comes
Got
from
it.
the global.
So yeah, I guess this is probably like a pattern that if you used effects quite a bit, then it's you'll know that there's like a few packages that you need all over the place, which don't really change too much based on like they have no you don't mutate them. It's like a standard library that you have around, the same way as like in JavaScript you have like promise everywhere, or like you have like you can say new image or whatever. So it's basically we're just exposing our standard library here for an effect program.
Which, if you comment out, you realize the other.
Oh yeah, let's actually do that. So if we were to comment this out, oh, very nice. All right, so here we already can't find that. Cool. But as said, like if you don't like that, if that's too much magic for you, and like I, for example, have not yet started to use TS Plus in some of my projects, then you could simply also do the same by saying import from effect core. And is there
you have to go /io/effect.
Okay. Let's get rid of them, like io/effect, and here.
And it's advisable from plain TypeScript to use the that notation.
Perfect. So I guess this literally just means the same, but here we don't need it. All right, great. So we have here our, oh boy. All right, so we have here our program. Here are globals. I think we don't need to come back to that. And then we have tests, because and the tests are sort of like a similar entry point here. So I guess that's why we have another global file here, and we have we're using vtest. And so we have a couple of other globals here, but let's look into our test here. Say assert is true. That sounds reasonable. If we say it's false, then I guess yes, this tells us. Nice. All right, so we have a working setup here. So I guess now is the right time to familiarize ourselves a little bit with our rover ambitions here and going to Mars. So Mike, how, like, me as like your engineer, what I like, here are my requirements, but if you were to break it down a bit more, like what is the first goal that we could sort of achieve? Where do we want to go today, and what can we achieve like in the next 10-15 minutes?
Look, I think there's usually two ways of doing things. One, it's the how you would build it in a traditional sense, which is more to start focusing on the business logic. What I sometimes do instead, with especially when I'm with effect, because I gain much more composability for free, I start to do things that I see are like needed. For example, you're gonna have to read a configuration file. You're gonna have to parse that configuration file to some structure. So you can either start concentrating on those small, I would call them infrastructural pieces, or start to tackle the problem from the domain logic. So to try to represent Mars as a planet, try to represent basically the rover position, and try to make the movement, which all of it is kind of pure pure logic because it's
Right.
basically mutating.
My suggestion would be, let's not get ahead of ourselves. Let's not build it super properly yet, even though that's what we're here for. But let's actually try to build like a teeny tiny baby version of it first that doesn't do like most of the features, that just like vertically kind of like does like a first like mini a first mini version of like what we want to do, like with a whole bunch of like config should be hard coded, etc., where we just cut a lot of corners just to get the ball rolling and get a bit more familiar, that we know, okay, this is the rough shape, that's what this should later be like. And then we can step by step, then we have a better understanding for like, oh, that thing we need to do much better. And then we
I
can...
think the only thing you need to do good from the start is the representation of like the planet.
the
It's
domain, basically.
described as basically as a bidimensional thing, but a bidimensional thing with a Pac-Man effect.
Okay,
So,
great.
like,
Let's do that. So
you have to model the Pac-Man effect at first, which is like a grid and somebody moving to the grid.
okay, so do we have sort of like should we create a little diagram of like what we want to do, or should we get in code right away?
I think we can get in code right away. It's not
okay
much.
So what I would do is like, I would probably, I don't have a thorough enough understanding yet of like what we want to do, so I won't try to set up all sorts of new files yet, so I'll just like start here.
That's a good thing.
So you set like, we have a rover, and you're saying like, let's start maybe on a just with types. That's what I'd like to do usually, and then we can like change it later if we need. So we have our type rover,
which is more of an interface rather
or is like
than
an interface. Not hugely important at this point, but interfaces are nice if you want to keep the name. All right. So,
but actually, for this phase, I think it's important because you said something nice, which is, I'm not yet familiar with the thing. I'm gonna start defining the types. Defining types, define names, define identities. So that's the basic of the domain language we're gonna have to use. So that's very important that those things are well named and the names are preserved.
Awesome. So what does a rover, like a rover obviously can have a lot of stuff and like can have a color and like a weight and whatnot, but maybe we don't need all of that here. So what are some of the things that we care about in our domain here?
We kind of care, but I wouldn't say we have a rover. I would say we have a rover state.
Okay.
Rather.
So we have a rover state, and the state is
kind of the
like,
current position.
Has this starting point. So it has like an X number and a Y number and a direction. So direction I already see here is like north, south, east, west. So that's for me, like, let's say direction, I would go about this, that I would say north, east, south, and west. Oh, I do not have Copilot here, unfortunately. That is, I have to do a lot of manual work. Anyway, direction.
Write a string. Okay.
So, what does this complain about here?
I think you have to save.
I think I have.
Did you enable ESLint?
Anyway, we'll get that. We'll get to that. Let's not get distracted by that. So we have a rover state, which is like the position and the direction. I guess we're gonna deal with a lot of positions later on, so maybe we just say position, and we say here X and Y. I'll actually use this as a tuple. Just, I guess that's feels appropriate here, but could be an object. Doesn't really matter, I guess. Position, position.
Typo.
Okay, cool. Then, what is next? The rover receives a character array of commands, implements commands that move the rover backwards and forwards, implement the commands that turn the rover left and right. So I'll just gonna write down like roughly what I understood, and then we can see whether this actually makes sense or not. So say a command here could be either forwards or backwards or left or right. So, and I suppose without even reading much further ahead, what I could make of this is like we start out in a certain rover state, we get some commands, and we either mutate the rover state or we like evolve them over the rover state. Is this roughly the direction that we're going in?
Roughly, yeah.
Okay. Should I read ahead here and see, or should we? Is this already a good foundation to go?
I think you have to also represent this is like the rover state, and this is over a planet. The planet set boundaries.
Okay, so I haven't heard anything about the planet yet, so let's read about this.
Oh, you haven't heard about a planet? It's in the dust. The rover is on Mars.
Sure, like, but I haven't read about it in the requirements yet. So, and as an engineer, I care about requirements, right? So implement.
So you basically got a rover state that points to nowhere, but yeah.
Okay, so implement wrapping at edges. Be careful. Planets are spheres. Connect the edge at the other edge. So set. No, this is a position.
You basically have a table size which defines the planet, and as I said, you have the Pacman effect. So if think about it like a square, and you have the rover in the middle. If you go up, 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 then you come down. And
got it. And how is it defined? Like when I'm hitting like an edge, how do I know where the edge is? Do we think it like 360 like degree, or do we?
No, you got an initial configuration which sets the dimension of the grid. It's x times y. So you have like Cartesian axis.
Got it. So I think in terms of a grid, not in terms like that's already simplified. I don't have to think in terms of like a sphere. Surface.
Yeah, if you want to do it in spherical conditions and everything else, we could do it. You would need 3 coordinates, not 2.
Yeah, no, I'm not too keen on like doing any sort of like projection math here. So this sounds simpler. So we have like a grid of sorts, or what do we have?
I think the planet basically has a dimension, a size, which is a width and a height.
Do we have like a interface planet, and that has like a size, and a size is what?
A width and a height.
Okay. Let's do this. Size, width, number, height, number. All right. And so here we have a size. What else? So yeah, there's like we got to keep in mind sort of like this wrapping at edges, what do you call like the Pac-Man effect? I guess we'll notice if this goes wrong. And then implement obstacle detection before each move to a new square. If a given sequence,
in the planet, you will have obstacles too, as a matter of points in the planet, and if the rover hits a point, it's gonna have to say.
Is an obstacle like just a point, or is it like an area?
You basically have one coordinate in x times y. Okay, this is another thing we should say. Those are not numbers, are integers.
Got it. I guess we'll come to that shortly.
It's more like a space battle.
Right, but like we're so I actually will now briefly TL draw, just like pull out little diagram here. So if this is our planet, our
You've
grid
got a
planet,
grid.
so this is our planet grid. By the way, in my opinion, the Earth is not flat, even though we're looking at a planet here, just for the record. But
it's wrapped at the edges. So this is actually a model of a sphere.
All right, great. So, and we basically have just like little, so we do not have like obstacles are not like areas like this, but obstacle is basically just like, little dots.
The point is it's like discrete. You have a grid, and in each grid you have those dots, but you can jump from places to places. It's basically all dotted. Consider those like pixels. You have number of pixels, and some pixels are colored.
Got it. So yeah, it's like basically if we would have like I don't know, like moth sheet paper where we have oops. I guess if we would have something like this, and then an obstacle is rather like here. And so this is our position basically. So there's like, yeah. Okay, got it. So this doesn't make like we'd have to think through like the grids all over, and then we know like the obstacles basically there. And the rover itself also has just the size of like one position.
Yeah, basically the rover jumps up one.
Got it. So the rover does not have like a size like this.
No.
But the rover itself is also just
a point.
Like occupy. Okay, it's very, very simplified. All right, cool. That works.
You can make it as complex as you want, of course.
No, I mean that's cool. So, did I close this? Let's. Where do we have our Mars rover Kata? Is this here? Yes. All right. Cool. All right. Back to this. So this is like the planet, and a planet has obstacles. And the obstacles are really also just like an array of positions, basically. Position. All right. Cool. So we are so far. Let's see what else we have here. Yeah. I guess so far we've like thought about the domain in terms of types, but I think this is a bit more like behavior. So what I have in mind, like a behavior, I would typically like think in terms of like a function. So let's say here we have like a function which is process commands, and so we're dealing with like rover state, and we have commands, which is command like this, and then we do something with it. This is how I. Oh, and I guess we don't. I guess the rover state could have the planet inside, but let's put the planet here. Planet. And I guess we now need to do something like for new commands of commands, and then we like do something. So that's like in very, very, very broad strokes, what we could do here. Does that sound right?
Kind of, yeah. Depends. Like you could model it as a pure function, and then ending up returning either the final rover state after the commands have been processed and the planet hasn't changed, or uh, you could model it more imperatively, thinking the rover state as a kind of a current rover state, and as an environmental reference, like and mutate it around, so you have a process that mutates effectively a reference pointing to the current state. Either way,
So
it's fine.
I'd like to keep it simple, and rather do it this way. Basically, process a command, returns a new rover state, and
You're gonna have
this
problems with
assumes
that, clearly. Soon you're gonna have problems, because what happens if you hit an obstacle? You have to return an error.
okay. Let's get to that. Or we maybe mutate the planet by destroying an obstacle. Maybe the rover wins.
Maybe the rover wins.
No, that
Look, I've implemented all the specs,
okay,
but the rover was so strong that
all right, let's get to that as we go, but like you already have obviously already more in mind here. But I guess just thinking about it, like what we have so far, I could probably do something along the lines of like, since here we probably want to do the same as like also returning a new rover state.
you're gonna have to reduce.
And I guess yeah, exactly. So I just say here commands reduce, and so here we want arc rover state new commands.
Well, you're gonna have to use the in JavaScript, this doesn't work very well. Reduce means just squashing the, you don't want to return a command at the end. So either you import.
Hold on, let me, oh wait. So let me just briefly write it out. So rover state planet command. So, and we would need to initiate this with the rover state. Shouldn't this do the trick?
Yeah, okay, this does the trick.
So
my point is, now it can't be inferred, or at least I don't think it can.
Yeah, let's do one at a time. Okay, so we have this so far. So here we got to do the actual useful stuff now, and I guess this could be a good time to do like some like lightweight TDD. So let's get to that, and we're I'll just like take the test. Actually I'm gonna do it like this, and so we have the tests on there. And so what I'll do, and by the way, so far this is just like me being slow at programming, but has very little to do with effect. But we will probably get to that effect part pretty soon. And I think as soon as like I hit like some more like non-trivial cases with like errors, etc., like you've already hinted at, this is probably where we're gonna indulge in some of these effect abstractions. But let's just briefly get through this. So here's like it's so this is like no obstacle planet. And here let's say for now we're dealing with a planet that is like very nice and does not have any obstacles. So move forward. So here we are. Let's first get our stuff here.
Probably gonna have to export everything, yeah.
I'll just export everything. Let's see, luckily I'm using Vim, so it's less laborious. All right. And so here I just say whatever, import everything as whatever Rover, or I'll just import it as app from.
Just use global.
Okay, it's another thing I'm not
Org
used
app.
to.
Org app
Org app
/ program.
Program. All right. Cool. So here I'll first create a planet and app planet, and this is, oh my, I'll probably switch over to VS Code shortly. This is getting a little bit annoying with my like browser shortcuts biting Gitpod shortcuts. So here I have a size, and as a size, I'll just say this is like 10 times 10, and obstacles has like no obstacles. And then as my initial rover state, rover state, here the position, let's say that's starting out at 0, 0. And well, actually we have to consider like what are the what does forward even mean? Or no, sorry, actually so the rover state faces in the direction and then forward. Okay.
Forward is forward on that direction. It's
direction.
not forward on the map. You're not telling the rover go north, south, you're telling it.
Okay.
Just like a car. Very weird car.
Right. All right. Cool. So it has a position, and but we still got to decide what
you have a position and the direction of the rover.
What 0 means in terms of, is it in terms of the
the easiest encode, the easiest
is like 0 here, or is 0 here, like that's what we gotta define.
Look,
I guess
this is kind of your pick, but if you want an advice for the Pacman effect to be simply a modulo division, 0 is the like bottom left corner.
All right, cool. I'll take that advice. So position
and 10 is the top right.
Node position 0, 0, or not, 0, 0 means bottom left, and then the like, I guess north means up.
What do you mean north?
Or like up? North means are we like with position 0, 0? Are we like in the north already, or are we in the south?
The direction is what it counts.
Yep.
So the direction is north. North points up.
That's what I meant. Yeah. Pointing up. So 0, 0. We're like at the bottom, I guess.
0, 0, we are at the bottom, but we can't be at the bottom looking up. We cannot be at the bottom looking right.
Totally.
Looking down.
But we're like at the bottom and looking up. So we're like at the southmost point.
this is an input, which is the initial position of the rover.
But like the initial means bottom left means south west most point, whatever, does English or not. But like okay, cool. So, and here we're starting all the way the like would actually be nice to have like a little thing that helps us draw this as I'm a visual person, but maybe we'll get to that at some point. So we are starting all the way bottom left, and let's make it easy, and we want to move north. So direction.
Let's say that we are looking north and we want to move up.
So yeah, exactly. So we are looking north and we want to move forward.
Yeah, move forward. That means go up, basically.
Exactly. Yeah. So let's say new Rover state. And here we are now doing our grandiose thing, process command, initial Rover state, planet, and now we want to move forward. Cool. So we want to now say expect.
Yes, I need to. I'm using asserts usually. If you want to use expect, just go in the global
I'm good
stuff.
with this. This is fine. To be and can I provide a parameter here?
It should be probably 2 equal.
2 equal. Cool. And so here I want to say true. This should be position. So the first is X, that doesn't change, but Y should change, and direction should be unchanged. So that should be still north. And guess what? It does not do the thing yet. All right. Yeah, let's build that. So we are saying now switch over the command.
I think you have called it commands, yeah.
So command, and we are interested in the case forward. Okay, like I'll do this just like hard coded, and then get to that one step at a time. So I just assume right now we're facing north, and I'll just I'll add another test case for that in a second, where then it's a wrong assumption, but let's get to that. So here I'm basically now saying so forward means we're not changing any direction. So we are actually here. I'll just deconstruct this. Oh my.
I'm laughing because there's no way you could ignore the current direction, but
of course, but we'll get to that. So here, direction, and I'll just.
You don't know what to change if you don't know the direction you're looking to.
Right now the program is hard coded for the test case we have, and then we'll evolve it. So position, here we'll just keep this, and position, actually
who's 0?
Yeah, posterior. Now it gets annoying, so I'll actually change this to this, that I can say dot x and dot y. Yeah, sometimes I think like a tuple will be great here, and then like the first moment I need is like never mind. So position x and y.
Max tuple has exactly the same problem.
y plus 1, because that's what I know we need. Cool. Here, x and y, and no, size is width and height. Okay. Cool.
Line 19. Two.
For at least, the very least, the next session, I will switch to my VS Code. But it's been nice. So what is going on here?
In the test, you have the wrong position in line 19. You haven't changed to X and Y.
Oh yeah.
But also you have a compilation error, which I don't know what it is.
Let's see.
This is old.
Let's grant ourselves a little bit more space here. Can I do? Anyway, so what is going on? Maybe this is just not.
Just check what's in build watch, because you have a build error.
Have a return.
Cannot find Rover state.
I have here direction. Everyone in the stream was probably like, "Oh my gosh, right there!" and I didn't see it anyway. Okay, cool. So we have it. The rover can move forward. Probably hits an obstacle very brutally, very quickly.
No, actually, the failing test is the same, exactly the same test with a different position, different initial direction, like looking south instead, or looking right, or looking east or west.
You mean to turn?
No, if the initial position, initial rover state, instead of direction north, you do it pointing to the right, forward means moving the X, doesn't mean moving the Y.
Yeah, totally. Absolutely. Yeah, this was an provocatively minimal. So I think so. There's like a lot of like pure logic stuff we can do here, like in order to like further implement this. But I think what we're here for is like to learn some like new programming patterns, etc. So I would choose the next step or the next failing or the next test in a direction where we would need to deal with like some sort of like error handling. So either like basically build more logic or do some error handling. So maybe as the next step, I could imagine we do like another test suite, which is like actually does have an obstacle, and where we place the obstacle right at like x0 and y1, and we drive forward and we hit the obstacle. And then we need to do some errors.
We could do that, or otherwise the other points in the specifications are like to load the initial position of the rover and the planet from configuration files, so there is the IO part. Whichever
let's do that in the future. I think this is let's start with this first.
Then we can introduce an obstacle.
But just so I understand, like what is like the desired behavior actually? Like if we were to hit an obstacle, how should we deal with it?
If you were to hit an obstacle, you should not move forward, but you get a sequence of commands. You don't get a single command. The spec is you get a sequence. So you have to imagine you get a sequence, and at some point on the sequence, you might encounter an obstacle. The rover has to move up to that point and return effectively the new state of the rover, so moved up to that point, and the fact that it has encountered an obstacle, so the CLI operator can go left and right accordingly. It's basically like a dumb machine. It receives a number
Got
of
it.
inputs.
And it basically
It
just
goes
ignores all follow-up commands?
precisely. It ignores anything follow-up and accepts new commands, but from that state. So considering the direction and the position it was on.
Okay, got it. Yeah, that makes sense. So my first instinct for this would be to actually have like to not just always return a rover state, but to return like, yeah, there's like a few ways how I could go about it. Like, even if I would ignore all the things I know from effect for now, like in the past, I would have maybe considered like throwing an error and then catching it up here, or I would return null or undefined, and then check for that. And so that would be for both of these approaches, like throwing an error and then catching it, or returning a null. There is an effect equivalent that is better. By better, you have to trust me here that it will be nicer further on when you build your app, and it's gonna unlock more good stuff like composability, etc. But that would be basically the path that I would choose. I would probably say here I either return a rover, or I would indicate, hey, I'm like not returning anything, and that symbolizes that I've hit an obstacle, unless I know that the requirements tell me like, hey, there's can be other cases in the future, such as like, I don't know, like I'm out of fuel or whatever. But for now, I would probably say I would turn this into an option. And that therefore this means like I either return hover state and rover rover state, or I return nothing. How
Could
does
be
this
actually
sound?
a really nice extension to consider fuel in the problem. I
Yeah.
would for
um,
workshops.
Yeah, I'm great with making problems worse than they are. Um, so yeah, then let's do that. So this is the first effects primitive that we can actually use now. So
And here you could simply choose an either,
I could do that as well, but I would probably go for an option.
I was more of the kind it might be better for you to go with effect, because you're gonna have to do many more things and the rest of your program will end up being an effect.
Okay,
So
so
composability will be way easier.
and
in the
therefore,
future.
like, you treat this as an error.
You treat that as an error case, yeah.
Okay, cool. So Mike, with the benefit of like forward-looking hindsight.
No, this is the good aspects of over engineering. Sometimes over engineering is bad. Here we are using something way more powerful to do something dumb.
Cool. All
but
right.
that will allow in the future of moving state to be a contextual thing and move all, like process command
Got
will
it.
only take a command and it's
Okay.
going to be an effect that
So
moves.
I'll just do this briefly in the non-effect way, and just that we had like some obstacle planets, so just that we get a feeling for like what we want to do. So we have now an obstacle danger. We have an obstacle at x0, y1. Yeah. And so we want to still do the same thing, move forward, and we'd actually expect this to yeah, let's take a look here shortly. but we expect this actually to right now. Yeah, let's write the test actually properly. Expect to throw. So this does not throw. So let's make it let's make it throw. So here we want to basically now check if, and we still like vastly oversimplify this and basically just assume the direction is like north, etc. But like we'll get to that. So we basically check. Let's say here we say new position, position, and we just do this. And new position. And now we are, what's this complaining about? Okay. Yeah, well, is lint very pedantic. Okay. So we want to check now basically, hey, does this planet have any obstacles at this new position? And so what I would do is basically like has collision. Is this how you write it? Whatever. Whatever. Probably was
collision, probably.
Holy shit.
Oh, yeah.
Okay, I'll just behave like I would normally behave. I Google this. I don't know. Collision. No, unless it means something else.
You wrote it
no.
good here and bad in the other file.
All right. Did I?
Yeah.
Well. Yeah. Okay. Fair enough. Collision. There we go. Okay, that was the hardest part of the session, by the way. So we have planets, obstacles, and I want to check whether some of these has basically, this is like an obstacle, and I want to check if the some obstacle x is new position x and obstacle y is new position y. And if that is the case, then we want to throw. If has collision, and if I would have Copilot, would have probably already written this. Anyway, throw new error Mayday. Okay. How does this look? Am I doing something stupid?
No, you have to format. It's pedantic, yes, lint problem.
But the test should do the thing. I don't know where the test is.
Giovanni is saying break statement. Switch case break. No, there's a return.
Yeah, but I mean, this should be throw, should throw. So throw, maybe I say error here.
No, but you don't expect the rover state to throw. You expect process command to throw. In the test.
Yeah. You are correct.
And you gotta have a lambda inside the expect, probably. Otherwise, I don't know how this could work.
Okay.
Maybe.
Aha, yes. Okay, cool. All right. So this is
where assert is nicer.
Sorry?
This is where our assert is nicer. If you do assert dot to throw, it's gonna.
Okay, fair enough. Anyway, so here we have now thrown an error. So, but this is obviously if we would now to use this here, then it would not, and I can't really use this reduce so as nicely anymore. So I wouldn't try catch, etc. And so one of the superpowers of effect that was actually like the main reason I started using it is like better error handling. And error handling is notoriously hard in like more traditional business logic programming. And so yeah, like if we are now introducing effect here, effect basically gives us similar like a function. And I'll oversimplify here, like Mike will probably cringe, but effect is, think about like effect like a function like we're writing here. But instead of just returning one thing here in the type signature, we actually also know what could go wrong. And there's like an equivalent to throwing errors. Like instead of throwing an error, you're basically just returning the error, similar to how like in Go, you either return the value or the error. We're doing something similar here. Yeah, and then we basically have an easier time to further up look, hey, has gone something wrong without catching it. We can just like use the return value. And we basically have like right now this function sort of like has one dimension that it returns, and we almost get like a second dimension where we can return an error. So this probably hopefully makes click for you a little bit. Maybe already has, maybe we'll do more in the future. But let's just do it, and then you'll see where we're going with this. So an effect is basically, we'll basically just say, we wrap this similar to how you can like say, hey, this is like a promise. A promise and an effect are sort of similar in the way how you can form an intuition about it, but an effect is like kind of like an even more advanced version of this, and you'll get to know some of the benefits soon. But so we're now basically saying, hey, we are returning an effect, and you see like these three channels here. R stands for environment, I guess.
It was requirements.
Requirement, whatever.
It's
like
gonna be C context.
We don't actually need it right now. So I'll just like leave it off and just say never, but we'll come back to that. Then E stands for the error. So here I'll actually just say, for now, I'll just reuse this error thing, and then we'll make it better.
Just use a string mayday.
Okay, let's use a string. Cool. And then the last part was like this A thing. A is like a comment. It's like in the effect ecosystem, like typically means like, hey, this is like the actual value that you wanna get. Anyway, so this is what we want to return. And now we basically need to make sure we can't just return a normal value. We just need to briefly wrap this into, as I said, like an effect has sort of like two return channels, either it's successful or it has failed. So we just need to now wrap this into effect dot succeed. Succeed is like, hey, it's been successful. And here we're saying, and by the way, type safety for this also works. So if I say here effect succeed, then I get here, like I get auto completion for this, which is nice. So, and the direction. And so this is where we want to change it now as well. And here in this case, we rather want to return not succeed, but failure. So we say effect fail may they. So and this is essentially it. This up here complains now because like this doesn't know about this effect thing yet. Actually, we don't need this right now, so I'll just comment it out. And we'll get to that shortly. But now our tests start failing because they don't know anything about effect yet. So let's get to just briefly making our the previous test happy again. So I'll for now just execute this one so that we can focus on this. And so this complains about like, hey, this thing is now looking like this effect succeed thing. So what I'll for now do, I suppose, is
You have to
my
convert
intuition tells me I could basically just compare it to like wrap this in effect succeed, but I'm not sure whether this is actually going to work. So
No, it's gonna work in this simple case because it has a value inside, but generally speaking, no, it should not work because effects like the description you've made, you said an effect is like a function. It's true, an effect is like a function that needs to be executed. So comparing two effects would be like comparing two functions, doesn't
got it. So we need to execute it first.
Yeah,
so
we need to execute
can
first.
I simply do this?
No, effect is not a function.
So it's not a function, but it's this effect thing. And so if we remember from the beginning, where we had our main entry point, we did that thing here, like program, unsave, run, promise, and then it actually is turned into a promise. Are we doing the same thing here?
You can, but I'm also gonna show you something more recent and experimental. You are not doing anything asynchronous.
Okay.
So you could do unsafe run sync.
Okay, let's do that. So we're saying
you wanted to
say
why is it only unsafe run price?
I guess we don't have this here. Run sync. Do we have this available here? No.
I need to check.
Oh, it does work. Okay. I guess maybe just like the auto completion has not caught up yet. But this works again. Great. So just to be sure we didn't mess up anything. Okay, cool. So if I add it again, then this works. Great. Cool. And then let's take a look at the other the other tests again. This is also failing. And so here we are no longer needing to do the to-throw error, but we can now do also the effect equivalent. And I suppose, well,
unsafe sync, unsafe run sync exit.
So let's actually do one thing briefly. If we were to do the same thing here, like we say unsafe run sync, then this would actually, yes, this actually behaves the same way, which is cool, just like from an intuition perspective. But later on, we actually want to like, there are nicer ways to work with this than like to throw and like to catch and blah blah blah. But we can actually get a thing, execute this, and get a thing back that we can now look at and say, hey, have you failed? Have you not failed? Without like these sort of without this approach. So Mike, I think you said something along the lines of like,
should be unsafe run sync exit, something like that.
Okay. So let's take
yes. No.
You sure?
No. Why don't you have auto completion? It's weird.
I do not know.
Check the build watch thing.
This is why I'm rather using stable tooling, but anyway, let me just restart my TypeScript server. That's something this code sometimes messes up. Yeah, I guess you'll look into this afterwards, but for now we'll just, well, it's kind of annoying to work with us now, like without having proper types. But I will I'll now say new rover state. And I for now say
No, there is an unsafe run sync exit. There is unsafe run sync exit, so you should find it. Unsafe run sync exit.
It's not showing. Maybe it's because it's in the.
No, it says identifier expected.
In the test?
You have another error.
So here I see it. Maybe it's because it's in the tests.
Check the global of the tests.
So here we have the
global.ts.
Oh yeah, we're missing the effect thing here.
Yeah, we're missing the effect thing. Import the effect thing here.
Okay.
And you can also use the type thing. Yeah. Sorry about that.
Oh yeah, well, whatever. We can adjust this later. But here we now have, oh yeah, this is much nicer. So here we now see, okay, see a signature for this, and we see a signature for this. And so here we see a thing called an exit. So that's new. What is, let me actually just like see what I got here. So new, let me do the thing that I do as a programmer, which is I log it. And yeah, so let me do this. Okay, so I have a thing failure and has a cause fail and has this tag failure. All right, so let's look into it. New rover state. So, okay, I have this tag. So tag is something you're gonna see a lot in effect. So when you have something that is like polymorphic, so union of something, then a tag is like a best practice that you put on all of these different union members to use that to differentiate, hey, what am I dealing with? And so in this case, it could be this exit.
You also have is failure and is success.
Yeah. But like here could basically be a string, which was our error value, or it could be a success, which is this rover state that we'd be interested in up top. And here at runtime, we saw, okay, we actually got a failure. So I think here we basically.
But a failure for effect, you see, you have a failure of a cause. So
right,
you don't really have either one.
Yeah,
or
this is
the
not
other.
the only knowledge we have, but we have like the actual knowledge of like the error. And like what's one of the nice things about this is like here we see directly, okay, this could be a string, but again, a string here was just our super lightweight way of like say, hey, our error right now is a string, but you could have like a much more sophisticated error type with all sorts of stuff in it. And in normal JavaScript, you would just have like try catch, and then catch is unknown or any. So this is already a really nice improvement for TypeScript. Anyway, so what else do now is rover state tag to equal. And here I want failure. So let's see that. This is green. Cool. And I guess what I could even do is saying oh well, I would need to I would need to
you could do something. You could do expect new rover state just without the tag to equal exit dot fail mayday.
Okay. Let's see what happens. Oh, there we go. All right, very cool. So yeah, I mean, right now we've just taken like the first baby steps to turn this into like an effect. So far, we've done the work. Was a bunch of work to type this, but we haven't really like reaped a lot of benefits yet. But I guess we should probably also like we might not get to that part fully during the session. So this was rather the session was rather like now to like learn about the domain, get to like take the first few steps. But I think that the real exciting effect bit's gonna rather be unleashed in the coming
there is
episode.
something we can do straight on, and it's converting the process commands function.
Let's do that as like as the last step.
Yeah.
So okay.
Here, the easiest way is with a friendly generator. So we can show generators and a for loop inside the generator.
Okay, cool. So a generator, what Mike is referring to here, is basically the same as like you would have.
I don't think I have it.
Okay, so it's here.
Sorry about that.
Like this. So a generator. This will look pretty weird.
You have to take a parameter.
Yeah, in here.
Yeah.
All right. So first, this will look rather weird. But this is basically at some point you'll forget about it. And you can think about it basically as like an async await kind of equivalent, but with kind of like the effect version of it that has better error handling, and like you get all sorts of like nice benefits from it. So you'll see that. For now, just don't be scared of it. And for now, what we're gonna do is say remove this.
Well, I would say to introduce a current state. I think you want to have a procedure and update the current state.
Okay, cool. Let's say current state, and this is Rover.
Or a reference to the current state.
And then we are saying const command of commands. And then we are so here we get our thing.
Oh, it's like it's literally current state equal yield.
Yeah, that makes sense. So yeah, since I guess you haven't seen that what is it, yields?
Yield star, and you have the also, yeah, the dollar code. I forgot to put the VS
typically
code.
There's like a little shortcut. So for now we're just saying process command.
Well, current state.
Sorry, current state, planet command. And let's see. So
and we want to return the current state at the end.
That's what we want to do indeed. Return current state. And so if we now look at this, we now see, okay, we have an effect that requires nothing, can fail with a string, and returns the Rover state. And what's cool is like here we provided it explicitly, which we wouldn't actually done. We wouldn't need it. But here it's like fully inferred. And this, I think, automatically basically has the behavior that we wanted. If we think back about the requirements, we basically, without having to do anything here, we would either, if everything goes well and we don't hit an obstacle, we return the last known good Rover state, and then it basically stops and doesn't do any more damage. Or if it would encounter an obstacle, it just stops there. And this yield basically is doing this basically like doing your happy path.
But actually, one part of missing behavior is that the rover should move up to the last state before hitting the obstacle. This moves, but it just returns the error. You have no way of knowing you've lost the last good state.
Oh yeah, that's actually a good point. Yeah, we just that's a great point. Let's do this as the very last thing, and then we're gonna
You want to do that?
wrap it up for
Look,
today.
I could say that the easiest way to do that is, instead of carrying around a rover state, just carry around a ref of the rover state, have process command, don't have process command return a new rover state, have process command mutate the reference of the current state.
Got it. Okay. I guess this is gonna be, so I think this is a more advanced solution to this problem than I would have maybe initially reached for. But it's probably gonna help us quite a bit. It's gonna probably scale better with further requirements. However, I would say if we're gonna do that, then we should probably take the time for it and do it next time properly.
Okay. Actually, could be very, very fast. Literally in line 25.
Okay, let's do it very briefly.
Line 23. Sorry.
But I still want to first take a brief moment before we dive into this. This may be still a nice point to take a brief moment to ask anyone from the audience, from the people who are listening live and watching live, if they're still awake, whether anyone has any questions, whether it's been clear so far. If I was in the audience, then I would probably, one of the biggest questions would be on my mind, if I wouldn't be familiar with effects yet, would probably like, why so much ceremony for like such a simple use case? And that is, for as far as we got so far, a valid point. But the idea behind effects is like that there's going to be like some threshold that you reach for like your app complexity and requirements, where now this like little bit going like a little bit further than you could usually express with code, now then like really unlocks a ton of value in the same way as like you could do like a hello world. You don't need React for that. You can just like do document, create element, blah, blah, blah. But very quickly, you're going to approach a point where components, etc., is like really nice to use and build your front-end app. And think about effects like components. They're just going to like, you're going to be very happy later on that all of your logic is an effect. And if you're into TypeScript, then you're going to be very amazed how much like effects and TypeScript together will help you. But yeah, so I don't see any immediate questions from the audience yet. So if you do have any, I guess we'll wrap it up in 5 minutes or so. Okay, I see one question. Doesn't make sense to put planets into rover state. I had like the same idea earlier on. I guess we could.
I could take that, given I've done the full exercise before. It does make sense if you keep this type of design, but you reach a more composable design, making both the planet, the rover state, and the planet environmental services, so you don't have to carry those around manually. So depends.
So environmental services for me sounded like, okay, this like, again, sounds like big cannons for like small problems. But the thing is, if we're gonna imagine, like here we have like all of these guys, and then we have this, and let's say we have like more functions or more effects further on, we always need to like pass them through, and it's gonna get really old real quick. And for cases like this, where like we always going to deal with the same planet, that for the planets and the rover state also doesn't change as often, it makes sense to make it available like in an easier way. And in React, for example, we have like the concept of React context, where we can provide a value and then access it. So that's kind of, Effect has a similar concept, which I guess we'll take a look at. Cool. Another question. Could we spend 2 minutes exploring the possible ways to describe the model's pros, cons in a functional way, if possible? I think Mike might have a more refined perspective on this. What I will say though is that I typically start somewhere, and as you whether it's like super functional or not, I just start somewhere and start building the app, and then at some point you realize, oh, like that thing here that I constantly have to do is like very inconvenient, and then I refactor it to something that's more convenient, and organically you end up with something that serves your use case nicely. So a small example of this has already been like, I started with the size and position as a tuple. Then I realized, okay, it's actually nicer for me to work with like position.x instead of position, like then access like 0 index or 1 index. And so, yeah, I think there's like a lot of, I think your intuition, you can lean on your intuition quite heavily, and you don't need to like get it right from the beginning. I think one of the things that TypeScript in effect really allows you to do and supports you much more with it is like get it wrong like 10 times, but it's really nice to refactor it and improve it. And so, yeah, my encouragement would be, let's not try to over engineer it from the beginning and get it right from the beginning, but rather like get good at like learning, iterating. So that's like a more general statement. But Mike, maybe you have
Yeah,
like
but I
some...
was about actually to confirm exactly what you described. One, usually, especially if this is a simple application, so we could take a board, design it all, define an understanding of everything, and just go on and write the code. That's not really the experience we get in real life whenever we have to develop something where the complexity kind of crosses the boundaries of a single whiteboard.
It doesn't work for project management with waterfall, and
doesn't work at all. The very own advantage of functional programming in general, if done well, and Effect, I believe, is one way of doing functional programming really well. That there might be different ways that scale exactly the same in different environments, but it's the ability to start easy and to change without really breaking anything. That starts from the model. As I said before, I know it's gonna be easier to move some things to like context, but just because I've done the exercise already, not because I knew that upfront. If I face it in app code, I would start precisely the same way, iterating it by bit. Maybe I would have different preferences. Instead of like have export type position, I would try to make more new types, more branding, kind of restrict on integer instead of numbers, but that's more personal preferences if you're speaking about
there's
data
a lot
modeling.
Of like choose your own adventure here.
There is a lot of choose your own adventure, but the process of progressive refinement is, you have described it perfectly.
Awesome. Cool. Mike, I know you wanted to do it like refactor it right away. I'm also keen on doing it, but I think we should like,
I just want to change 2 lines. And
2 lines,
show
and then
you 2-line changes.
Okay.
I'm not touching process commands, and lucky for you, the tests you made are only on process command. Okay. So we're gonna do it without touching process command. We're only gonna change process commands. Instead of taking Rover state, take Rover state, which is a ref of Rover state.
Okay.
Just type ref.
Like here?
No, as an input.
Like here?
Yes.
Okay.
Good.
So ref seems to be another magical effect thing that we have not learned about yet, and I think we will probably not get a solid understanding of it today, but in the next session. Okay, but it seems like TypeScript is telling us we need to do one more thing.
We need to do like a little bit more than one thing. There's current state.
You tricked me.
Equal rover state dot get, line 25. You've just reassigned its dot get, and you have to yield that. No, it's together. So it's
okay, so
get.
it's just like that, and we're yielding it again. Okay, so here we got a normal rover state, and I suppose
then after having set in line 27 current state, this is fine.
Got it.
As a next thing, you update the reference.
Got it. So we're saying here
rover state dot set.
We're wait a second, but we're like over. Oh no. Okay, we're saying rover. I see. Okay, and now it also has made click for me, because this rover state thing here is not like a single variable that we're passing in, but it's actually like a reference that we further out can still later on come back to and like read it.
Now this, whenever it blows up, the caller has the last updated reference.
If we set it, yeah.
If we set it, precisely.
Got it.
And to set it, you need a
and so this thing as well here is again an effect, and whenever we're dealing with an effect, there's like a promise that you need to await, otherwise it doesn't do the thing properly. So that's what we're doing here.
That's it.
And yeah, so again, these generators and this yield stuff, etc., and like ref, etc., it might feel like a little bit of like, why are we doing all of this? But yeah, just get used to it, and then you'll you have more and more points where you realize how nicely things click together like Lego, and then you'll like feel happy that you have gone through like and just like started using some of these abstractions. Like Mike's been working with these abstractions for many years, and like making this available to more people, I think is gonna pay off. Cool. So I think
as promised, it was 2 lines of code changed.
Well, 1, 2, 3, almost
3 if you consider a
close
time.
enough.
Close enough.
Cool. Yeah. Joseph says Joseph never really understood refs properly, and that we should talk about it more the next time. I think we will. Maybe some of the last comments have also helped about it, but we'll dig more. Like the next time we need to actually call that thing, and so and we'll start writing some tests with ref, etc. So we'll have to better understand it, and yeah, then I'm sure we'll get a better understanding of it. Okay, cool. I guess we'll wrap it up for now. I hope for everyone in the stream, and I hope everyone watching the video later, that this will be helpful. Yeah, took a little bit of time to just like get going with everything, but it's always the same with like a new project. We have to learn about the domain, project setup, etc. So, but I think we will get some nice momentum the next few times. Hope to see you around the next time. Hopefully, probably like in 1 or 2 weeks.
We're gonna get to game design next time.
All right, exciting. All right,
good.
Then thanks to all of you for showing up, asking great questions, and thanks, Mike, for guiding me through here, getting to Mars.
Thanks to you. It was really a pleasure.
All right, I'm gonna take a shower now. It's very hot here.
37 degrees, you said. Bye-bye.
Bye.